As we discussed last class, why Snowflake? The major first important point is hybrid architecture. So which includes shared disk and shared nothing elements. Okay. So and the other one is storage and computing are separate. You want to go with storage capacities, you can go with storage capacities. If you want to go with the computer, you can go and increase your computer. If you want to decrease your computer, you can decrease your computer. If you want to decrease your storage, you can decrease it. Why? Because storage and computer are separate for the Snowflake. And coming to the storage point of view, like whatever the data coming from the different range of sources, actually, let's say for example, this is my Snowflake. Okay, assume that this is my Snowflake, and this account was created with the AWS provider, cloud provider for compute and storage. Compute and storage. Okay. So let's say the data coming from the different range of sources into a Snowflake like this. Okay. Now Snowflake will process the data with the help of what is the concept? Compute power. Virtual warehouse. Virtual warehouse. With the help of virtual warehouses, okay, this Snowflake will process the data. The help of virtual warehouses, this virtual warehouse is nothing but computer power in Snowflake. Computer power in Snowflake. Computer power in Snowflake. So it will load the data into Snowflake. Snowflake, what it will do? It will store the data into a storages. Yes or no? It will store the data into a storages. It will store storages called example AWS ES3. Okay. So AWS S3. How it will be stored? The form of please tell me, in the form of, you already know this. In the form of hybrid columnar storage. Means combination of rows and columnar partition. Means combination rows and column. So whatever the data coming from the different data sources, okay, will be stored into Snowflake, okay, which was a cloud provider. Storage is a cloud provider. So on the cloud provider, the data will be stored into the form of hybrid columnar storage. That is the means of combination of row and columnar format. Okay. So let's check what is columnar partition, what is columnar hybrid columnar partition. Let's say, for example, the records will be stored in the form of row wise as well as a columnar partitions. Let's say, for example, if you talk about the databases, okay, almost all the databases will follows the row partitions. So why? Because the databases are very flexible to add some data and modify some data. Okay, needs to be flexible to add some data and modify data. For writing speed, writing, it will be decided. Okay, so databases for the writing speed. Okay, so in this case, these databases, almost databases are following the row partitions, row storages. That means the records will be stored in the form of row wise records in the form of row wise like this. Okay, and also in this scenario, in this row storages, what will happen means while searching for the specific data, so unnecessarily you need to search for the whatever the required data is not required data also you need to search. Let's say might read in unnecessary data also while searching your data. Let's say you want a specific data from the these storages, so that it might needs to read unnecessary data also. Okay, that times they will get a chance of performance issues. Okay, but most of that row storages are good for adding some data and modifying some data and updating some data. Okay, so for the databases are definitely reliable for that adding, modifying and updating. Okay, so for that row partition is good for databases. But coming to the data warehouses, so mostly they will work with the reading purpose. So many people will read some data. Okay, so in this case, row storages will affect some performance issues. So for that, most of the data warehouses, okay, let's say for example, starting from Hadoop, okay, Redshift, BigQuery, Synopsys, all these all are following a columnar format. That means the records is stored in a column wise. Only need to read in relevant data by using a columnar storage. While searching your data, you can search your relevant data only. Triple writing requires multiple accesses, but it will be suitable for read mostly read intensive large data repositories for column repository. What is columnar format means? Columnar data format have become the standard in the data lake storage for fast analytics workloads as opposed to the row format. Columnar format significantly reduce the amount of data that needs to fetch by accessing columns that are relevant to the workloads. So do you got my point here? So where we have a row storages and other one is a columnar storages, where we have a data storages, what we can call it as a data warehouses. The data warehouses, almost data warehouses will follow say columnar storage. Columnar storage is very flexible to read the relevant data, and also it is suitable for read mostly, read intensively, and large data repositories. Where we have a data warehouse, we maintain a use and bulk of data only. In this case, columnar format is strictly recommended. Okay, now what is the specialty with Snowflake? What is the specialty with Snowflake? If you observe the specialty, so in this case, if you follow the row storages, that time adding, modifying, updating is easy, but might be read unnecessary data, so that there is a chance of performance issues. That's the first point. And the second point is, if you are following a columnar storage, yes, it is suitable for read mostly, read intensively, large data repositories, and also it will read relevant data. Okay, fine. Then what about writing? If you want to write something to the data warehouse, that time definitely these columnar storages are not good. Definitely. Okay, but compared to row storages, definitely columnar storages are not better performed than row storages on writing. Why? Because row storages will be writing suitable for writing most. Where we have a columnar storage is reading most. But I want both means columnar storage, it is not possible, no? Now, if you talk about a Snowflake, yes, if you check in the Google also, it will say that Snowflake follows a columnar format only. Snowflake follows a columnar format only. But in detailedly, if you talk about a storage, again I'm repeating, in detailedly, if you talk about our storages of Snowflake, that time definitely you need to must and say that it is a hybrid columnar storage. That means it is a combination of row and columnar partitions. That means the data will be stored in row wise as well as a column wise. So that for both read and write, Snowflake will be the better suitable. You got my point or not? Yes.
Sir.
So, sir, okay. Snowflake is following a both row-wise and columnar partition. How it will be maintain your data into a columnar partition and row-wise partition. See, let's just go with the theoretical operation so that we have a dedicated class for this, how it will be stored and how it will be maintained. But later we will talk about it later. Okay.
Excuse me, sir.
But you can check here. The data will be, let's say, for example, you have a big file. Okay, you want to process the data into a Snowflake. That big file is automatically converted into small parts of your file, call it as chunks. Again, I'm repeating, a big file will be automatically converted into a small parts of your file. Call it as a chunks. These chunks will be call it as a micro partitions. Micro partitions. These micro partitions, if you observe, this is one micro partition. Okay, let's say you have a record of this one. Okay, this is the table. Okay, this table entirely a logical structure of your data. So what will happen once you load this table into the Snowflake, what it will do, it will identify one cluster key. It will identify one cluster key. So based on the cluster key, okay, let's say for example, based on the ID or based on the cluster key, what it will do, it will create some partitions like partition 1, partition 2, partition 3, partition 4. These all call it as a micro partitions. Okay, these micro partitions will maintain the data. See, if you observe, this is the records of row wise and these partitions are as column wise. That means the data was stored in the row wise, whereas micro partitions was column wise. It is a combination of row and columnar format. You got my point here?
Excuse me, sir.
Yes, please.
If Snowflake is using services from cloud providers, that is storage and computational power, then Snowflake will have to use their storage framework, no?
Yes, but here the cloud platforms, whatever the storages it will be, you can modify as per your wishes. Why? Because that is just a simply file system. Hadoop file system, like whatever the HDFS file system, even all cloud storages also follow same file system.
So if we are using storage system of AWS or say Azure, so will it be possible to modify them to hybrid storage?
It
Like this?
won't be modified. It won't be modified. Any file can be stored. But whatever the data on the Snowflake having some logical structure, and based on the logical structure, they maintain the data like this. It is in the form of files only. The data is in the form of files, but the logical structure designed for that file will be like this.
Okay, sir.
Okay, so whatever the file system you have, you can use whatever you want. The file system will support for whatever you want, but that needs to be designed. So whereas Snowflake logical structure will be like that, so that whatever the data will be in the form of files only, definitely. Okay, files are something like that, file system only. But the file system was designed with this logical structure with the help of Snowflake. So let's say, for example, if you choose another environment, okay, choose a columnar format like a Redshift. Redshift again, it will maintain the data into S3 only, na? Like
Yes, sir.
synopsis, you choose a synopsis. Synopsis also needs to store their data into a Azure Blob or data lakes only, na?
Yes, sir.
Then how these storages will support for columnar format? Needs to be in files only, na? Why? How it will be supports? With the help of logical structures. Clear?
Yes, sir.
Is directly table will fit on file system? Is it possible to create a table on file system?
Sir, I did not understand your question.
Is it possible to create a table on file system?
Yes, sir.
Directly table.
No, sir. We will have to write a schema pointing towards the flat file stored in the storage system.
Yes, absolutely. That is one structure.
Yes.
So that tables will be in the part of files. If you open the CSV file, the tables we have, multiple tables we have. Same
Mm.
like that. That is a just a file systems. You can use whatever you want. But
Yes.
that needs to be designed as a logical structure.
Yes, sir. Got it.
So that Snowflake will design some physical structure of the data in the form of micro partitions. Okay. In the micro partitions, if you observe, the records on that logical structure table will be in the row wise. And then the partitions was in the column wise. And this partition will be no user interference. Okay. Snowflake will do automatically. Snowflake will do automatically, and this size of micro partition will be in between 50 MB to 500 MB, and there is no definition for that. One micro partition will be this size and all micro partitions will be this size. Okay, on that time Snowflake feels that, okay, what is the size of micro partition, that size will be designed. Some micro partition will be in 50 MB. Some other micro partitions are in 300 MB. Some micro partitions are 500 MB. Some micro partitions are 60 MB only. Okay. So based on the cluster key, Snowflake will automatically do these micro partitions. If you observe these micro partitions, the records of logical structure will be in the row wise, and this micro partitions was in the column wise. So that every micro partition having a metadata, how many records you have, how many records you have in that micro partition, and what is the minimum value and what is the maximum value for that micro partition. Let's say I will show you one image so that you can easily understand that one. So we have a dedicated class for this, but don't worry about it. For understanding purpose. That's if you observe, this is my records. Snowflake automatically choose a cluster key with a DOB date. That means year. So what it will happen? This is one micro partition and this is micro 1, 2, 3, 4, 5. Overall of 20 records, it will create a 5 micro partitions. Assume that it will create a 5 micro partitions. Now, if you observe, so based on the cluster key, what will happen? 1995, 1997, 90. Based on the 1995 to 2008, the years are there. So in between the records, it will create some micro partition. Now for this micro partition, what is minimum value and maximum value, and how many records you have, and what is the date range for that? Every metadata will be updated here. Metadata will be updated here. Now your statement like select star from customer where year equals to 1995. Immediately how many partitions it will check? Tell me. So minimum value in the first micro partition, the
1.
1995, so that it will match for one partition, so that it will read one partition of it. You got my point, sir?
Yes,
Shall I
sir.
repeat again? Please respond.
Yes, sir.
Yes, sir.
We get your point.
Yes, for to repeat or understand?
Understand, sir.
Understand.
Good to understand. Okay, so again we have a dedicated class, but you try to understand what is micro partition exactly. So what we have micro partition. Let's say for example, this is the query. Select star from customer where year equals to 1997. If you observe 97, minimum value and maximum value, it is a part of 97 means maximum is 97 year and minimum is 97 year. So that it is a part of 1997 is a part of two micro partitions. It will read two micro partitions to get the data in this query. Let's say, for example, this is the query 2003. So where year equals to 2003. It will only find out the minimum and maximum value. Minimum value is here 1997. It not match for 2003. Okay, maximum value is matching. Okay, good. Maximum value is matching. And after that, what it will happen? What is the maximum value, minimum value? All will match. Check. Now tell me how many partitions it will check. It will check 4 partitions. Like that, it will search your data. How many partitions you want, you can create it, sir. No problem. So n number of partitions you can create. Whatever partitions you want. So unlikely traditional static partitions, Snowflake micro partitions are derived automatically. They don't need to explicitly defined up print or maintained by user. As the user suggests that micro partitions are smaller in size, 50 to 500 MB before compression. After also it will maintain some compression also. So after creating a micro partitions, it will store the data in compressed format, which enables extremely efficient DML and fine graining tuning for the fast queries. Micro partitions can overlap in their range of values, which combined with their uniformly small size helps prevent skew. Columns are stored independently within micro partition, often referred to the columnar storage. This enables efficient scanning of individual columns. Only the columns referred by a query are scanned. Columns are also compressed individually within the micro partition. Snowflake automatically determines the most efficient compressed algorithm for the columns in the each micro partition. No user interface, sir. Everything will be done with a Snowflake. Clear, sir? So with the help of these micro partitions, so you are getting fast and efficient results. Even at the any complex queries also, you are getting fast and efficient results. So Snowflake will be a hybrid columnar storage. Now see, sir, if you observe, this is my Snowflake as we discussed right now. Okay, so if you want storing your data or computing your data, if you deploy your Snowflake into AWS will provide you computing and storage. Now if you get a storage from AWS, this AWS S3 will store the data in the form of hybrid columnar storage like this. And in the Snowflake, metadata will be updated, and this metadata will be pointing to your actual raw data. Whereas S3 will store the raw data in the form of micro partitions in the compressed format, and this data will be searched by metadata on the Snowflake. Let's say if you want to query your data in the Snowflake itself, you will create a virtual warehouses, and how many virtual warehouses you want, how much computer power you want, you can define with the help of virtual warehouses, so that AWS will provide the computing power to the virtual warehouses or in the form of Snowflake. So now what is metadata? Anybody knows? What is metadata? What is metadata?
The details of the data is metadata.
Details means
File size, storage location, etc.
yes. Let's say, for example, I have a table, ID, name, salary, and then I have some 5 records. Now tell me, is entire table we call it as a raw data or metadata? Is any metadata is available on the table?
Yes,
No,
sir.
sir. It is raw data.
Yes, complete table will be a raw data. So some people thinks that headings like column names are call it as a metadata. So it's a wrong, sir. Entire table with a column names also be a metadata. Okay, sorry, raw data. So what is metadata? What is the time when it will be created? Okay, what is the file name, and what is the size of that file, and how many records you have? What is the minimum value? What is the maximum value for that particular table? So these all are the metadata which will pointing to your raw data. For understanding purpose, let's say you have a photo image. Okay, that image we call it as a raw data. Okay, that entire image will call it as a raw data. Okay, what is metadata? Who will click that photo and where it was clicked and who is participated in that photo? Okay, and what is the region and what is the time for clicking that, which camera we used to click that photo? These all are the metadata. Got my point, sir?
Yes.
In more understanding, all you know that Natu song, Triple R movie, Natu song.
Yes.
All you guys know?
Yes, sir.
Yes, sir.
This famous song, I think so. That's why I just discussing about it. That entire Natu song we consider as a raw data. Then what about metadata on that Natu song? Who sung that song? Who play the music for that song? And who danced for that song? And where it was shooted? These all will be pointing to that song. That is called actual metadata. Clear, sir?
Yes, sir.
Now, next, storage is a hybrid columnar storage. Next, micro partitions are automatically and auto optimizers. Let's say, for example, if you want to query if you want to do optimization for your query, no need, sir. Snowflake will take care about it automatically. Almost all cloud data warehouses will take care about auto optimizers. Auto optimizers optimize their queries automatically by their own products like Snowflake, even Redshift, BigQuery, all will automatically optimize their queries and performances. Okay. Next, coming to that, where one of the best features in Snowflake is time travel. In other platforms, there is no this type of option. Okay, so there we have another option, but it is the best feature, best feature in the Snowflake, time travel. Let's say, for example, yesterday we have one class. We already have done with one class. Somebody missed that class. Is any chance to go and take the class live on yesterday?
No.
No.
Live not possible. Recording
Live.
we can see.
Yes, I want live.
No.
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 So is any time travel mission is there?
No.
No.
Time travel mission like Aditya 365 mission or any time travel mission you have, you can travel on the time and you can go now. So in some movies, some missions will come and heroes will go and travel on time. Na? Is it possible at that way?
No.
No.
In cinematic way? No.
No.
But in the Snowflake, let's say 10 days back, if you delete some data, Okay, let's say 50 days back, if you delete some data, let's say 70 days back, you unfortunately updated all the records instead of updating one record. Say 70 days back, instead of updating one record, you updated all the records. You forget to mention where class. You got my point?
Yes.
Now, how to retrieve that one? You simply, in Snowflake, you can travel on time and up to 90 days, you can make it as a correct. Up to 90 days, you can make it as a correct. 10 days back, you delete the data or delete the table, you can just undo the table. Just unroll the table. If you update something, okay, the updated table will be there. Okay, fine, no problem. But before that time, you can go with a old data also. So there is a time travel. With the help of time, you can go and travel on the time. With the help of time travel feature, you can go and travel on the time up to 90 days. So that means your data is available up to 90 days based on the types of tables. Let's say if it is a permanent table, so you'll get 90 days time travel period. So even though if you've done any wrong on the table, up to 90 days, there is a possibility to retrieve the data. You got my point? So in other technologies, there we have a flashback time. So that flashback time will store the whatever the deleted data or wrongly updated data. So that that time will be also around 24 hours to 48 hours based on the company requirements. Okay. So in this case, after that, we can't retrieve the data. So, but in the Snowflake, up to 90 days, you can go. Sir, 90 days is also not sufficient to you feel. You feel 90 days is also not sufficient. There we have an extra 7 days. So, but no user interference here. If you contact to Snowflake in the time of database failure or any other things, okay. So you will get the data also with after extra 7 days also. That means 97 days your data is in safe hands. Got my point, sir?
Yes, sir.
Simple statements are select statement. With the help of simple select statement, attend before offset. Okay, at means at that time, before means before this query, offset means before 10 seconds, before 1 day, before 10 days, before 6 days, before 70 days, offset. Like that simple select statement, we can go and travel on the time. And easily we can retrieve your data within simple seconds. Clear? That's one of the best features in Snowflake. So time travel and file safe. Time travel will be 90 days based on the types of table. File safe is extra 7 days. Need to contact to Snowflake, no user interference. Next, data sharing. So most of the data sharings will be somewhat complex, whereas, for example, if you observe data sharing, okay, this is my data consumer, data provider. Okay, so you want to share your data to the vendors, like for example, market data needs to share with sales team. Okay, and for example, some hospitals needs to share patients data to the so and so pharmatic team. Okay, pharma or any product based teams. okay, to go with the best inventories. Okay, so in this case, definitely any industry, the data sharing is must and should. So, but in the traditional format, what will happen? For example, you have a 10 GB data to share. This 10 GB data needs to be created as a copy. Okay, created as a copy like this, and after that, the data will be shared to the data consumers by moving the data consumers by moving this data to the consumers like this, by moving the data like this. Let's say if any new data will be there, again new data will be created, and then the data will be moved to consumers again. Got my point? So that means there is no security, and also there is no live data for the data consumers to consume. This is somewhat difficult task, but in the Snowflake it is simple, sir. If you have a Snowflake account, if you have a, let's say if you have a, this is my consumer account, this is the account number, and this is my Snowflake account, this is account number, assume that. So in this account, provider account, we will create a one share name is share. In the share we will add a db, for example db1, and this db will be attached to the Snowflake account like this. So automatically this share will becomes on the consumer's place also. So immediately the share will be utilized by a consumer. He will access. Consumer can access live data updated on provider. So this is the way in the Snowflake easily you can share your data. So it is very secure, sir. Why? Because this data consumers only get read only access. Only they get read read only access. So that these guys don't have misuse, they don't have chance to misuse your data, and also is getting all live data also. Why? Because whatever the data updated on this database object will be updated in the share also. Automatically they will get a live data. This is the possibility. Let's say for example, sir, you are telling you, so there have a Snowflake account, but my consumer is not willing to be a licensed Snowflake person. Then at that time, how we will share the data? This consumer, whatever the consumer you have, is not willing to be a Snowflake person. So at that time, what we will do? Simply, what we will do, in our account itself, we will create one reader account. Snowflake reader account. It will give some URL. Okay. And we will share this URL to the so and so consumer. Reader account URL. With this account, this consumer can access. So instead of here, you can write this is the reader account. And we will add reader account here. Same process. We'll create a reader account and we'll share this URL to the consumer. Okay, consumer. Okay, and the consumer account will be added in the share. So automatically same process, the share will be connected to this reader account. Reader account can access directly with the help of that share. Easy process. So no moving of data, no bothering of security, and no bothering of live data. Everything will be done. Clear? Any question? Next, zero copy cloning. What is cloning? Anybody knows? Please tell me. What is cloning? What is cloning?
Exact copy of data.
Exact copy of data. Let's say, for example, this is my table. Table is 100 GB, for example. This is T1. Now what I am doing, this T1 is pointing here. We already discussed now, whatever the data is in the micro partitions now. So that this table is pointing to, assume that this table is pointing to. So don't ask me, this micro partition is around 50 to 500 MB only, sir. How 100 GB is in 3 partitions? Just for example, I am telling, sir. Okay. So just assume that 3 micro partitions were connected with 100 GB. This is P1. This is P2. And this is P3. Now, what I am doing, I am making this copy. I am making this as a copy. Now tell me, sir, what is actual storage, sir?
100 GB.
100 GB only.
200 GB.
So this is 100 GB. Actual storage is
100 GB.
200 GB. But in the Snowflake, it is only 100 GB. Let's say, for example, we already discussed where we have 100 GB. I am copying this one. Let's say, for example, this is my okay, data files. How much size it is? Properties 157 MB. Just what I am doing, copy, paste it. I'm creating a one copy here. Now tell me what is the size for me, my local system.
Same
This
size.
is 157 and this is 157. Almost 300 MB.
Yes, sir.
Yes or no? This
Yes,
is
sir.
actually copying the data. Okay. Yes, here also same I done. See if you observe. Whatever the 100 GB I'm making as a copy. That means totally how much? 200 GB.
200.
But in the Snowflake, it is 100 GB only. Why? Because for this, it will pointing here. You have already a partition, storage partition, na? It will be pointing here. Let's say you insert some data here. Let's say, for example, some 50 GB of data you inserted. Now tell me what is the size, sir? Totally actual size 250. But in the Snowflake, it is 150 only. So whatever the increased 50 GB, it will create a one partition, another partition. Like this. And that will be pointing. This is P4. P4. Let's say, for example, you increase something here. You increase something here like 200 GB. You increase something here like 200 GB. For this 200 GB, what it will happen? It will create another partitions. And it will create like this. Now tell me what is actual storage, sir? Now
450.
actual storage is 450 GB. Then Snowflake
150.
350.
350. Yes.
350 extra 200 GB, no? This 100 GB, 50 GB, 150 GB, and then 200, 350 GB. Now, if you observe, this is P6, P7, P8, P9. Now, what I am doing, sir, I am just cloning this data, sir. I'm cloning the data. Now tell me, sir, what is our storage? Same 350 only, sir. But here, actual storage is normally how much? Extra some 300 is added, 750 will be.
750.
But in the Snowflake, only it is 350. Why? Because this table will be pointing to actual. This is the table clone now. Entire table clone. Same partition. Got my point? If any DML operation will be happen, for that also one more partition will be there. There is no limit. You can create n number of partitions. Okay, so Snowflake will create n number of partitions, millions, thousands, lakhs of partitions also. Sir, if you create a lakhs of partitions, is any performance issues, sir? Sir, definitely performance issues will be there, sir. Why? Because so, but it is negligible, sir. Negligible. Why? Because Snowflake have a strategy to update as everything as a metadata. Let's say, for example, you delete this table, sir. You delete this table. Now, is any effect on T1 C1, sir? Is any effect on T1 C1?
No.
No,
No, sir.
it should not be.
Now, for example, you delete this table, sir. Is any effect on T1 C1 C2?
No.
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 Partitions will be there. Sir, if you observe, these two tables are deleting. This table will be pointing to this only. That means that for these partitions, any table is not pointing means immediately the data will be updated. Metadata will be updated for that partition. No data, no table is pointing, so that it won't read it. Why? Because at the time of searching your data, first Snowflake prune your data, which was not a part of your data. Like it exclude the partitions first. Got my point?
No, sir. Can you repeat, please?
Yes, I will open that image and I will show you so that it will understand. First, pure micro partitions that are not need for this query. Then pune by column within the remaining micro partitions. First, it will check that which is not a part of a query. Let's say, for example, if a query is there, the query, it will check how many micro partitions you need to read and what are the micro partitions you don't need first. First, it will check what are the micro partitions we don't need. Let's say, for example, for these two partitions, no data is pointing. So metadata is already there. So it was not pointing to anyone, so that it will be in the immutable, like some ideal. But where we have these all partitions are connected to other table. So whether it will check whether this partition is part of that table or not, it will check. If it is not there, it will say that it is not a part of that query, and it won't read that partition. Got my point, sir? All DML
Yes,
operations like insert, update, delete. Okay, if anything will require, definitely it will create one more micro partition. Thousands, lakhs of partitions also can create. It won't affect the performances because of everything will know by Snowflake, because Snowflake having a brain of system. In other ways also, these micro partitions are available. Let's say, for example, Hadoop. In Oracle also, we have a micro partition system. Yes or no? Are you there? Do you know that one?
Yes.
Do you know that one?
Sir, we have not heard about micro partitions, but partitions are there.
The name micro partition you didn't. Partitions are there. Like
Yes.
for example, hash partitions. Yes.
Yes, yes, sir.
And also we have what we can call three partitions are there. What the names we have? Forgot. List partition, range partition, and hash partitions. List means, for example, region wise. For example, this region sales data into a one partition, or specific region say partition data into a one partition, like that. So where we have a range partition means from year to this date, from this month to this month, that is a range partition. Hash partition means a specific number of records into a one partition, specific number of records into one partition. In these partitions, what will happen is the partitions will be created, but it is too complex to design actually. So it is too complex to identify the specific data into a which partition. So why? Because for IO operations and data transformations are very cost performant. Why? Because they don't know where that exactly available. Why? Because they don't have any brain of system. We need a brain of system. So, but if you talk about a Snowflake cloud service layer act as a brain of system. Brain of system will read it and identify it, which partition, where the data needs to be maintained and where you need to maintain in the form of cluster keys. And after maintaining the data into a micro partitions also, again, same brain of system will identify the same data. It is easy, na? Let's say, for example, you hide something, and again you are finding that that something. It is easy or not? For example, you hide something, I am finding that ID. How much time it will take?
It is difficult to find, sir.
Simple concept. So same cloud service layer, brain of system is maintaining everything, and same cloud service layer is searching the data based on your query. So this cloud service layer act as a brain of system. This brain will identify the data and it will apply the cluster keys and it will maintain the micro partitions. And again, while query is running, so this brain of system is going and execute the query on the same micro partitions. Why? Because this brain of system will knows everything. Got my point, sir?
Yes, sir.
No. Okay, this way. Next, zero copy cloning is not actual copy. It is just a copy of data. So it won't consider any extra storages. And task and streams, one of the most important. What is, did you heard about anywhere task and streams? Task and streams. Anywhere did you heard about it?
No, sir.
No. Are you from SQL backgrounds? You didn't heard about the task and streams? Let's say, for example, this is my source table. And this is my target table. This is my target table. Let's say, for example, this is my records. Assume that this is my records. Okay. What my intention is, I want to make these records as it is in the target table. That means every time I want to make source table equals to target table. Like development table equals to production table. Got my point, sir? Every time I want to make source table equals to target table. Let's say if any record was updated here, the records needs to be updated in the target table. So normal process, what will happen? This entire source table will be trying to copied here. That time already copied data needs to be replaced, overridden. Otherwise, it will check that whether the record is there or not. Like it will check and it will it will append the record, whatever the records not available on the target table. This is the two methods actually. But my intention is that only I want to update this changes data only. So for that, we will create a one stream. What is that? Stream. Did you heard about the CDC? Change in data capturing. Change in data captures. So it will only captures the changes happened on the source table. Why? Because you create a stream on the source table. Only this captures this one here. And as it easily, this will be updated. We will have a one condition on the manually. We will run a one merge command. So merge command will immediately update the data into this way. Let's say if any changes happened here, like this. This will be also captured by stream, and this stream data will be updated into the target table. Like that, every time you can make a source table equals to target table. Only if any DML operations was happened, to just delete this one. This will be updated. This will be updated here. And this will be updated here. Like that, it will try to make equal, makes everything equal. Okay. Sir, every time merge command needs to be run manually. It is possible? Every time. Is it possible to run this merge commands manually? Please respond.
No, sir.
So for that, we will create one task. What is that? Task. In the task, we will create the schedules. Let's say, for example, 1 minute or 10 minutes, for example. So every 10 minutes or every 1 minute, it will go and check the stream. If any stream data will be there, that will be updated on the target table. Got my point, sir? Here, stream is change in data capturing. It will capture only changes happened on the source table. Whereas task means it will call it as a scheduler. Any question?
No, sir. Get it.
So this why all these are possibilities in the Snowflake. There is many more, sir. Many more. Anywhere did you heard about swapping? Swapping. What is swapping actually? What is swapping? For example, A equals to 1, B equals to 2. Swap A, B. Swap A and B. Now tell me what is your answer?
A is equal to 2 and B is equal to 1.
So swapping, that is correct. A equals to 2 and B equals to 1. This is your result actually. Let's say, for example, you have a table like T1. The table is T1. And these have 100 records. It is in the development. It is in the production table. Production environment. Prod environment. Okay. And I have a T1 underscore test table is there. And it consists of 200 records. Got my point, sir? Are you understanding or not? It is in the development environment. You got my point or not? Are you understanding or not?
Yes, sir.
Let's say now the test was done and I feel that these 200 records needs to be updated on the production environment. In real time, what will happen means if you want to update the whatever the tested code needs to be updated on production means there is some methods. Manual method is there, automation method is there. Let's say, for example, manual method means so the naming conversions of the production table is different. You need to change that into a naming conversion and you need to process it. And after that, you need to delete the whatever the testing or present exiting version like that. Otherwise, you will maintain some version of a particular file. This is somewhat difficult task. But here in the Snowflake, simply what they will do, It will create sapping. That's it. So that this table 1 will be sapped. So that this table 1 metadata will be pointing to this 100 record, 200 records, and this table 1 test record will be pointing to 100 records. So immediately T1 will updated with a 200 records. Only metadata will be updated, sir. Only metadata will be swapped. Got my point, sir? So if metadata will be updated, means what will happen, sir? T1 will be pointing to the 200 records, huh? So the T1 is a production table. So the immediately T1 will be updated with 200 records. Got my point or not? Shall I repeat again? Yes or no?
Repeat, sir.
Let's say, for example, there is a swapping. Swapping is nothing but just converting the values, data. So here, let's say I have a one table T1. It is a production table. T1 considered as a production table, whereas T1 test is a test table. Okay. So, but here in my test table, I have 200 records. In the production table, 100 records are there. Now I want to update the test table into a production environment. So in the olden traditions, what will happen is you need to update this table into the T1, or you need to add entire records into the table. That is somewhat difficult task. Instead of going with that of normal traditional activity, we'll just do swapping. See, swap between T1 and T1 test. So immediately this T1 will be considered into a 200 records, and a T1 test is considered as a 100 records. So what is your intention? You need to maintain 200 records on T1 or not? Now it was updated or not?
Yes, sir. But we are not swapping tables. We are just swapping the pointers that pointing to the.
That pointing will be in our Snowflake. If you understand the concept called micro partition, the table will be pointing to the specific micro partition storage.
Yes.
Then whatever it may be, no?
Yes, yes.
We don't need any adding data or making extra data or extra storages. Just pointing is enough, now. We have already immutable tables, immutable micro partitions. Sorry, no, immutable micro partition. Immutable means unchanged partition.
Unchangeable. Yes.
The simple task. This is one of the best reasons. And one more reason we have. Did you add about sampling? Did you add about sampling? Anywhere, anytime? Sampling. Anytime. In your words, please tell me what is sampling.
Portion of data.
Yes, portion of data out of lakhs of records.
Right.
1% of data, 2% of data. Let's say in next 6 months we'll get elections. So some media people will give some reviews, like some what we can do reviews or something like election predictance. How they will do, how they will predict you, how surveys will do. They will talk with all 100 crore people, around 70 to 80 crore people having a votes. Okay, all 70 to 80 crore people will talk by that survey guys.
No.
What they will do? For example, in a village, some 2000 people are there. They will talk with 20 people. Like that. Every constitution, you have a 1 crore people. For example, some 50 lakhs people. So they will take 1% or 2% people and find out their opinions. Based on their opinions, they will give a exiting polls. Yes or no?
Yes.
Yes, sir.
Same like that. For example, you have a crores of records. For example, you have 1 crore record. In that 1 crore record, assume that we have a some people are there, living conditions. Okay, the data is about some peoples. Okay, so in that table, there we have a one column called apartments, independent houses, okay, rented houses, and not applicable houses. So 4 types of housing types are there, like apartments, independent, commercial, okay, rented, and not applicable. 5 types of housing types are there. Now tell me, how many people are from apartment? How many people are living on apartments? How much percentage of people are living on independent houses? How many percentage of people are living on so and so not applicable? How many percentage people are living on commercial flats? Is it possible to go with 100 crore people, to check with 100 crore people? 100 crore records you have, sir. Let's say 1 crore record you have. Is it possible to go and check on 1 crore people? So
No.
how many
No,
living? How
obviously
many
no,
people
No.
are
sir.
living on apartments? How many people are living on so and so commercial flats? How many people are? How many percentage of people are living on so and so individual? Is it possible, sir?
No, no.
No. Just we'll create one sampling. Let's say 10% sampling or 2% sampling, and we will do that activity. 10% sampling means crore means 1 lakh people. Yes or no? 1 lakh or no? 1 lakh only, 10% yes. Or 1% means 10,000. Out of 1 crore, you just check with 10,000 people is enough. You'll get easy answer. Exact answer also. That type of sampling analysis also you can create. That's one of the best features. In other technologies also it will be there, but I am talking about Snowflake. So definitely I need to highlight the Snowflake. Any question?
Sir, in the previous example of swapping, can we use the other table, that is T1 underscore test, in the production environment directly without swapping?
Yes, you can use it. You can use same table into the production also without swapping.
So then what is the need of swapping, sir?
I'm sorry?
Then what is the need of swapping?
Not a need actually here. You can use some, but some in some environments, some critical tasks will be there for making the test environment into a production. Okay. So to avoid the critical tasking, the swapping is simple doing. That's it. In some environment, deployments will be there, and you need to do automation deployments, and you need to take the backup. Something different operations are there. To avoid to avoid that such type of activities, swapping is the one of the feature. So whether you want to use or we not use, why? Because see here, so Snowflake is a latest tool, and we are covering lot many operations, but still some are not understandable. Maybe in future we will go and do that activities. So your wish, sir. If you want, that is one feature we have. So if your requirement is there, it is simple to do that things. Clear, sir? Yes or no?
Yes, sir, clear.
Anybody having any questions on why? Anybody having any questions on why?
No, no.
Now, complete about the storage. We talk about the storages actually. Okay. Now, as we discussed, like this is my Snowflake. with AWS, assume that AWS. Now, if you talk about S3, is the storage, and EC2 is the compute power. So, like this, it will be there. But here, the storage will be in hybrid. Tell me.
Columnar.
Columnar storage. Then what about EC? And this have metadata. Metadata will be pointing on actual raw data. This is metadata. This is raw data. Actual raw data. Clear? Now, Snowflake needs a computing power. That computing power in the AWS means EC2 service. EC2 service. But this EC2 will be in the form of clusters. Did you complete this concept? In the form of clusters. Anybody knows about what is cluster?
Yes, sir. It is a collection of machines.
It is a collection of nodes.
Nodes.
Yeah.
So in the form of clusters, you need to define that is virtual warehouse. Name it as a virtual warehouse. In Snowflake, there is a concept called virtual warehouse. So you need to define the virtual warehouse. So based on the virtual warehouses, how you will get a computer power. You will get a computer power. You got my point here? Okay. So that means in Snowflake, the computer power are virtual warehouses. Virtual warehouse. Virtual warehouse is a computer mission or power in Snowflake. Snowflake in the form of clusters. In the form of clusters. And these clusters are or deployed into cloud vendors. Got my point, sir? Like AWS, Azure, GCP. Yes or no, sir? Please try to read this concept and ask your question. Oh, no problem. See, warehouse in the Snowflake is a virtual warehouses, is a computer machine in the form of clusters. The clusters are deployed into AWS, Azure, and GCP, and only metadata is maintained on Snowflake. Got my point, sir? Here, the clusters you are defining on the virtual warehouse will be range of 1 to 10 needs to be configured. So within 1 to 10 clusters, you need to configure, sir. So that Based on the configuration, this virtual warehouse will get computing power from the AWS, Azure, GCP at the time of account creation, which cloud you are choosing, from that you will get. Got my point, or sir? Yes or no?
Yes.
Let's say, for example, I have some virtual warehouse one, WH1. This is the name of WH1. In the WH1, you need to say something like how many clusters you want, how many, what is minimum cluster, cluster, and maximum cluster. You need to say these two, sir. And also size of cluster, size of warehouse, sorry, size of warehouse, whether it is a small, whether it is a medium, XS, or small, or medium, or large, or X large, or so and so, double X large. Got my point, sir?
Yes.
And so and so. And also you need to say type, whether it is standard or economic. Clear, sir? So virtual warehouse. Virtual warehouse will be defined with minimum cluster, maximum cluster, size, and type. Let's say assume that example WH1. WH1 minimum equals to 1, maximum equals to 3. Minimum 1, maximum 3. Okay. Now size is equals to medium. Size equals to medium. Now tell me. Type equals to standard. I am using normal one. Standard is the best one, sir. So what is difference between standard and economic? I will tell you later. Just choose a standard. Got my point, sir?
Sir, by size, you are referring to storage capacity or what?
Node capacity in the cluster.
Means RAM.
Not computer power. So CPU and RAM.
Okay, sir.
Processing power.
Here no storage actually. CPU and RAM only. Virtual warehouse means CPU and RAM.
Okay, sir.
Storage already discussed, na? S3 will maintain micro partitions, hybrid columnar storage.
Yes, sir.
Now only discussing computing. Computing means only CPU and RAM. I already discussed, na? Computing and storage are separate.
Yes,
Yes,
sir.
sir.
Now see, sir. Let's say, for example, this is my warehouse, WH1, minimum 1, maximum 3. Let's assume that this is one cluster. And this is one, you said that minimum is medium. Size is medium. That means medium size means it's a 8 nodes. 8 nodes. Eight nodes means, sir? Please tell me. 8 nodes means
8 machines.
8 missions on the cluster. This is C1. Now, is this warehouse size of 3, na? Maximum 3, na? Just make 3. This is C1. This is C2. And this is C3. So, sir, you have a data in S3 storage in the form of micro partitions, hybrid columnar storage. Now I have a requirement to query some data. I have a requirement to query data. To query your data, what you need, sir? To query your data, what you need, sir? What we need, sir? To query your data?
Processing power.
Processing power, computing power. Let's say I am choosing WH1 warehouse, which was created by you. That is WH1. Now I need to query 100 queries. So first 10 queries. So that means I have some load to query your data. So for that, the first cluster will be active. Immediately, the cluster 1 will be active. Okay, this cluster 1 will be active. And it will engage one node to process our data. But still, you are not sufficient your processor capacity. Now, what you need to do, sir? You need to engage one more. Manual process, I am telling, sir. Still queries are running, sir. Okay. So don't go with manual. Still queries are running, sir. Immediately, third node will be engaged. Still queries are needs to run, sir. More load is coming. Fourth node is engaged. Like vice versa, sir. Still load is coming. Like vice versa. Entire cluster was busy, sir. Entire cluster was busy, sir, right now. But still load is coming, sir. You need to process more, sir. Now tell me, sir, what will happen, sir? Now tell me what will happen.
It will choose second cluster.
Yes, it will add one more cluster. Entire cluster will be active, sir. Entire cluster will be active. Only first one node will be involved in the process, engaged. And next, based on the load, second, third, fourth, fifth, sixth, seventh, eighth. Now, entire cluster will be filled, sir. Still loads are coming, sir. Still loads are coming. Now tell me, sir. What we need to do, sir?
Another
cluster you need to add, sir. So entire cluster will be active. Okay, immediately. Entire cluster will be active. In that one by one node, it will be engaged. Now tell me. Now all three clusters are busy, but still you are getting loads. Is any possibility, sir? Any possibilities?
No, sir.
No possibilities. Why? Because your warehouse WH1 is minimum 1, maximum 3. The three clusters are engaged. Now, you are getting more loads means, what are the two possibilities? One is whether you want to shift the loads to the another warehouse, WH2, or you need to reconfigure the WH1. Got my point, sir? The first point is shift the load to another warehouse, or second point is, tell me please.
Reconfigure the existing one.
Reconfigure existing one. Reconfigure existing warehouse. Here, if you reconfigure the existing one, if you choose, if you use a shift to another warehouse, what will happen, sir? Let's say, for example, there is a caches. So every warehouse having a own local caches. So at the same type of queries, if you are running on the same warehouse, that time you will get a very good performances. So if you are running the same query in another warehouse, again it will needs to search the raw data. That will take more time. So that time some difficulties will be faced with another warehouse shifting. Got my point? So that better to go on reconfigure the exiting warehouse. So in exiting reconfiguring the exiting warehouse, two possibilities again, two options we have. One is increasing size of warehouse. What my points are?
Yes, sir.
Increasing size of warehouse. Otherwise, increasing the clusters. Increasing the cluster range. Got my point, sir? Let's say you just keep this as a L to M to L. So automatically the nodes on the cluster will be increased. How many nodes it will be there, I will show you later. Forget about it. Just understand the concept first. Got my point, sir? So if the nodes are increasing means processor capacity also increased or not?
Yes, sir. Processor capacity increased.
So otherwise, to just increase the, for example, maximum 5. So it will add another 2 clusters. So that three clusters will be engaged also. 4th cluster will go and process your data. Clear, sir? Yes, sir. No. Please
Yes,
tell
sir,
me.
clear.
Now, there is a 2 concepts. This virtual warehouse will support for vertical scaling and horizontal scaling. Vertical scaling and horizontal scaling. Vertical scaling means increasing the nodes, increasing and decreasing, the nodes within the cluster, within the cluster. Snowflake will support for both scaling, sir, horizontal and vertical. And horizontal scaling means increasing the increase and decreasing the clusters within the warehouse, Okay, that means that here vertical means we just say it as a scale up, scale down. Horizontal means scale out and scale in. That means here this is medium to X large or X large to small. X large to small. This is 1 cluster to 5 clusters or 10 to 4 clusters. Whether it is increasing or decreasing. clusters. Sir, nodes are increasing within the cluster means vertical scaling, scale up and scale down. Clusters are increasing within the warehouse means two options in that. Clusters are increasing within the cluster range means it is a scale out and scaling. That means clusters are within the warehouses. Sir, whatever the vertical scaling and horizontal scaling, it will be automatically done by Snowflake based on your configuration. Based on your configuration, your minimum cluster is 1, maximum is 5. So it will engage 5 clusters and it will automatically adding clusters and decreasing the clusters based on your workloads. Got my point, sir?
Sir,
Yes.
sir, but vertical scaling means only add the power.
Computing power. Whatever it is, both are computing power only, sir. Let's say, for example, we have 5 people. 5 people having own energy. Okay. So one person added another person. That is node increasing. Okay. Node increasing. So 5 people are in one cluster. So one person capacity will be added with another person means it's a node increasing. Same five people with one cluster, same another cluster is there. 5 people with one cluster. So cluster to cluster means how many people are adding? 5 people to 5 people is adding. That means how much capacity it will increase. Same, whether it is a node increasing or whether it is a cluster increasing. Both are computer increasing only, processor increasing only. Clear?
Yes, sir. And sir, reconfigure existing warehouse means increase the size and cluster.
I'm sorry.
There are two: shift the load and the reconfiguration existing warehouse, right?
Easy for wish. Easy for wish. You can use another warehouses. Two options are there. Two things are there. One is shift the load to another warehouse. Otherwise, reconfigure exiting warehouse is also fine. If you want to reconfigure exiting warehouse, two options again: increasing size or adding the clusters. The clusters will be possible up to range between 1 to 10. But size increasing means from XS to double XL. Triple XL also, 5XL will also possible. That means from one node to 5 to 12 nodes you can increase within the cluster. One node, starting from one node to XS means one node. Medium means 8 nodes. No? XS means one node. 5XL means 5XL means 5 to 12 nodes. That means within the cluster 5 to 12 nodes also you can keep. But you need to choose a size equals to 5XL. The cost will be also different, sir.
Okay, sir.
What happened? All are silent. Are you understanding or not? Sir, these all are for theoretical understanding only. Everything will be shown as a practicals and everything will be automatical here. Once you set up, everything will be automatical here. Any question on this? Please ask me. Otherwise, I will move to next. Please respond. If you don't understand also, nothing will happen. Please ask. Please tell me. Scale up means servers within the cluster. Increasing nodes, servers within the cluster. Scale down means servers within the cluster. Reducing nodes within the cluster, like small to medium, medium to small. That is vertical scaling. Horizontal scaling means scale in, scale out. Removing unwanted clusters from the warehouse limit 4 to 2, reducing clusters, or adding more clusters to the exiting list of warehouses 2 to 4, increasing clusters. That is automatically. It is automatically. So that's all I think. So enough today. So last class you asked about various data services used in different clouds. So I have an image for that. I'm just opening that one. Somewhere it was downloaded. See, this is actually AWS big data pipelines on AWS, Microsoft Azure, and GCP. So first, cloud computing powers like triggering powers and computing power lambda functions, and this is Kinesis, Streams, and Firehouses is data injection tools. And after that, AWS IoT devices will be connected like this. And after that, the storages like Glassary and S3 is as a storages, and Glue is a ETL. And after that, again, analyticals like Kinesis Analytics or EMR or SigMaker are using to do some analytical operations. Hello. Yes, sir. Classroom. Redshift is the big query here. Okay. So, and after that, there we have a quick site or lambda functions again used to do some operations with a presentation. So injection, data like storages, preparation and computing like ETL, segregations, and data warehouse is for like Redshift, and then lambda functions and quick site and other presentation tools are there. This is about AWS. Now Azure. Azure IoT Hub, Azure Functions, Event Hub. It is the triggered functions. And after that, storages like Azure Data Lake Storage or Azure Blob. And Data Factory, ETL. ETL is the data factory, like ADF. And after that, Synopsys is the data warehouse. And after that, again, Cosmo DBs, these are all the databases. Okay. And after that, Power BI is a visualization tool, presentation. Now, Google Cloud. Cloud IoT, Cloud Function, and PubSub. These all are the triggering and data injection tools. And cloud storage is some of the storage. And these are the ETL operations like data prep and data proc and data flows are the ETL operations. Like in different streams, we can use different operations. And AutoML, in machine learning algorithms, we will use AutoML. And there we have a storages like big table, cloud data storages, cloud SQL, and PubSub and data catalogs. These all are the databases actually in the Google. And BigQuery is the data warehouse. And then again, data lab and data studio and cloud functions are using for the presentation. Clear? That's all enough today. So we'll meet on Monday. So that's all enough today. Thank you. Thanks for your time. Do you have any questions? You can ask me.
Sir,
Yes.
sir, some of the features of this Snowflake are similar to Databricks. So are they alternatives of each other?
Databricks. What is mean by Databricks? Tell me.
Data is a big data analytics tool, no, sir?
Not purpose of Databricks.
Sir, for analyzing and querying big data.
Processing data.
Databricks is a unified open analytical platform for building, deploying, sharing, and maintaining enterprise-grade data analytics and AI solution at scale. The Databricks Lakehouse platform integrates with a cloud storages and security in your cloud account. The manage and deploys cloud infrastructure on behalf. At first, it will act as a computer engine. Okay, that's the first point. And after that, it will maintain entire deployments, analytical platforms, and everything. It just maintain everything in sequence, or we just say that we just erase the deployments cloud infrastructure on behalf of other activities. Like Databricks will combine everything, but here Databricks won't act as a data warehouse. So every features will be similar. If you talk about SQL, if you talk about Oracle, most all features will be similar, but the strategies and implementation will be different. That's the main important. And then Databricks is different, as well as data warehouse is different. Databricks won't act as a data warehouse. Let's say to process your use amount of data to the synopsis, we will use a Databricks. Why synopsis instead of you are using a Databricks? Is Spark and Hadoop is same?
No, sir.
Same. Databricks and synopsis is same?
No, sir.
Oh, sir.
Then you can use Databricks with Snowflake also. It is acts as a more computing power. It is used to create a platform, but the Databricks won't act as a data warehouse. So Spark, do you know the Spark? What is Spark?
Yes, sir. It is a processing engine.
Same. Databricks also same, but Spark will be in on-prem. It is in on-prem. It will be a combination of Hadoop. Hadoop is on-prem. So for the Spark with on-prem is good. Spark with Hadoop is good. Then where about Databricks? Databricks for the cloud. Databricks for the cloud, same like a Spark, Databricks will work. So similar to the Databricks is Spark. Spark for on-prem, whereas cloud for Databricks. It is a compute engine. You got my point here?
Yes, sir.
Sir, there is another product called Azure Databricks. Whereas Databricks and Azure Databricks is different. Yes or no? Do you know that?
Yes, sir. We use Databricks and Azure in combination sometimes.
Azure Databricks is different and Databricks is different. Databricks for every environment. Azure Databricks is for the Microsoft products. So to do some analytical operations after ADF and synopsis, we will in between that we will use the Azure Databricks. Some changes as happening within the Azure Databricks. Same Databricks, it will works as a compute engine only, but some strategy will be changed. That's we named as a Azure Databricks. So what is the main difference between Spark and Databricks? Yes, both are same, sir. Why? Two. Why? Because this Spark needs a cluster to do some operations. This computer engine needs a cluster. So where we have a Hadoop needs a cluster. So with the Hadoop cluster, this Spark will do the operations. But whereas Databricks won't need any clusters to act as a compute engine. That's the main difference. But both are same. What my point, sir?
Yes, sir.
Any question? I think tomorrow also they scheduled the class, but no class on tomorrow. We'll meet on Monday.
Okay, sir.
So any questions, please ask me. Otherwise, I will close the session.
No.
No doubts? At least are you understanding my concepts or my classes? I shall give the response so that I have some I will get some input from you so that I will change accordingly.
Understanding, sir.
I'm sorry.
Understanding, sir.
Other guys.
Yes, able to understand.
Good. Anyways, we'll meet on Monday. Please revise these classes. Okay. So whatever the classes I right now I teach. So please go through this revision. So on Monday, what we will do? So we'll just go through the revising of all these two topics. Okay. And after that, we'll start showing everything on PPT. So just I will revise everything on PPT. And after that, I will go to start installing the Snowflake account and I will start doing operations on Snowflake account.
Sir,
Yes.
I have a doubt. You please go to swapping window
I'm sorry.
where you expand swapping.
I'm sorry, I'm not getting it.
He has
Hello?
doubt in swapping concepts. Sir.
Okay, tell me. That was closed actually. Now tell me what is your doubt.
Yeah.
Yes.
Sir, if we have t1.test table, then we create another table with cloning called
Yes.
t3.test.
You can create it, no problem. Whatever things, everything will be cloned, but the cloning also created on the test environment only. No? But here in our practice, everything will be one environment. But in real time, then we have a test environment, development environment, and production environments are there. So in which environment you are cloning? Test or development environment, not on production. Production will be only confirmed data, finalized data. Yes or no?
Yes, yes.
So I feel that these 200 are confirmed data. That's why I just make some swapping to make these 200 records into a production environment. That's it. That's all enough today. Thank you. Thank you so much. Bye. Have a nice day.